Hello there, gang. So this is going to be an example of the spreadsheet part of the first homework. Basically, we're going to do the first two steps of the investor's problem. We're going to define the inputs to the algorithm. That means we're going to find the expected returns and covariances. And then we're going to find the weights that give us the best risk portfolio of the two risky assets we have to work with. In other words, we're going to maximize the Sharpe ratio like we talked about in class. The Sharpe ratio, remember, is defined as, right here, the risk premium on the portfolio we form divided by its standard deviation. Now, the expected return of P and the standard deviation of P both are defined by the weights. So as what we're going to do is we're going to let solver pick these weights, in other words, pick expected returns and P, such that we make the Sharpe ratio as big as possible. The weights have to add up to 1, and in the first case, and if we don't allow any short sales, then we can add another constraint. I'll show you how to do that so that the weights have to be positive. We'll save the third step of the investor's problem, maximizing utility, until next week, next time we meet. All right, so I have data for two firms, SBC and TiVo. Scroll down, this should be in your file. First thing I want to do is put in the standard deviations. I could have, and expected returns for these things. I could, of course, go to data analysis, descriptive statistics, and generate means and standard deviations and variances and all that junk, but we don't need all that for this part. So we're just going to put in the individual formulas. So I'm going to say equals stdev.s for sample, open paren, grab SBC's data, and there's the standard deviation of SBC, 10.66% per month. Let's do the same thing for TiVo, equals stdev dot S for sample, not population. The dot P is for population. The difference between those two formulas is that 1 divides by T, 1 divides by T minus 1. Highlight my TiVo data, hit enter. Wow, already we can see that TiVo is a lot riskier than SPC. It varies. Its standard deviation is 35.21% per month, while SPC's is only 10.66. All right, to get the expected returns, those are just averages. So we'll say equals average, open paren. We'll go up here to SBC, grab SBC's data, hit enter. We can see that we get 0.9%, almost 0.1%, or 1% per month from SBC, equals average, type, grab TiVo, and TiVo gets a little bit more expected return, given it as a higher risk. All right, we're going to put in some weights just to start with. These are what the solver's going to pick to make our portfolio have the highest Sharpe ratio, but for right now we'll just put in 1 and 0 just as starting values for solver, and also to check our formulas. All right, covariance matrix. Promised you guys I would show you how to do this. Remember, we went to generate the covariance matrix. We're going to go to the data tab again, data analysis, covariance, and you can see that I already have selected my data in here because I ran through the problem earlier, but let me delete that. So I'll just select TiVo and SBC's data. I did grab my labels, if you notice. So if you do that, make sure labels are clicked in the first row. If not, uncheck that, because otherwise it'll chop off the first row of data. Click your cursor in here, tell it what output range, and then click output range so that it can tell you, so you can tell covariance tool where to put the output. I just stuck it anywhere right here. Okay, notice that the covariance tool outputs a lower diagonal matrix, and we need a full matrix to do the math with. So in other words, we need to fill in this spot. Also remember that this is a covariance matrix, so this number represents the covariance between SBC and SBC, which is its variance. This number represents the covariance between TiVo and TiVo, which is its variance, TiVo's variance. And here, this number is the covariance between TiVo and SBC. So the number we're missing is the covariance between SBC and TiVo, which is exactly the same number as the covariance between TiVo and SBC. So really, we just want to copy this number up here. In this case, because I only have one covariance that I need to move to the upper diagonal, I could just copy and paste it. But on your homework, you're going to have like 5 assets to work with. So it's a little more tedious. And if you have a bigger portfolio of 15, 20 assets, let me show you a trick that works much better. Highlight the numbers, copy them, paste them next door, but paste special. And the paste special command we're going to use is we're going to transpose these things. Transposing the matrix will flip it over. So notice that the diagonal terms haven't changed, but the off-diagonal term has been flipped over because the transpose makes the first row the first column, second row the second column. And this will work with bigger matrices too. Now that I've got it flipped, I'm going to copy that again. Copy what I just flipped, the transpose matrix. Choose the first cell of my covariance matrix. Right click and do a paste special. And here I want to skip blanks. Make sure skip blanks is there. Say OK. Bada boom. Check it out. Now we have it automatically copied those over for me. Let me clean things up a little bit. Get rid of this. Let me get rid of all my border lines because they bug me. And then I will copy these data into my covariance spot. So copy and put your covariance measures right here. Paste them right there. All right. So step 1's done. Step 2, we need to set up for the problem so that solver can find us the optimal weights. And optimal weights are going to be found by picking weights to maximize the Sharpe ratio. All right, let's start off by putting in our formula for the expected return of our portfolio, which is going to be a combination of these 2 assets, SBC and TiVo. Now, if you remember, the formula for the expected return of a portfolio that in matrix notation, which is super easy, is just the transpose of W times E, where W is a vector of weights and E is a vector of expected returns. Okay, so here's my expected returns. I've highlighted these already. I've gone up here and I clicked and I typed capital E. So this vector is named E. Go to my weights, highlight those, go up here and name them W. Here I'm going to highlight my covariances, go up here and I named them capital O for omega because I'm going to need those later. All right, let me go back here. So let me calculate the expected return of my portfolio P as the multiplication of the transpose of W times the vector E. So that's going to be in the matrix math here equals MMULT, open paren, transpose, open paren, W. Notice how it highlighted the weight vector for me there. So we got everything named right. I'm multiplying the transpose of W times the vector E. Close that. There's my multiplication W prime E. This is just the weighted average of the expected returns. Control Shift Enter to make it work. And you can see that the expected return of my portfolio right now is identical to the expected return of SBC, as it should be, because I have my weight set up where I'm putting all of my money in SBC and none of it in TiVo. So my portfolio P consists only of SBC, so I should have the same expected return. That's just a check on my formulas. If I switch them, make this one 0 and the next one 1, the expected return on my portfolio should be the same as it is for TiVo because I'm investing everything in TiVo. So it looks like my formula is right. All right, now I need the standard deviation of my portfolio. Well, the formula, that's just going to be the square root of the formula for the variance of a portfolio of assets. So equals SQRT open paren. That's how you take a square root. Now, if you remember the formula, you can look in the notes. The formula is for the variance of a portfolio of assets is W prime omega W. So I want to take the matrix multiplication of the transpose of W and omega. Take that answer and matrix multiply it against W. Take the square root of all that junk, and I should get my standard deviation of my portfolio back. Here's the formula. Equals square root open paren. Let me do my outer M mult. This is my second one, MMULT. My inner one, MMULT. All right, so my inner one's going to be the M mult of the transpose of W and omega omega. There's my first multiplication. I'm going to take that answer and I'm going to m-mult it against w. So that's w prime omega w. And then let me close the square root. Hold Control, hold Shift, hit Enter. And there's the standard deviation of my portfolio. Notice that it's pretty close to the standard deviation of TiVo. Again, because I'm investing everything in TiVo, my portfolio is the same is essentially just TiVo. These numbers are not identical because I'm building my standard deviation based on these covariance estimates. And I told that story about how the covariance estimator in Excel divides by t instead of t minus 1. Here, this is dividing by t minus 1. So you can see there's the difference. And using just t instead of t minus 1 makes our standard deviation a little bit smaller. All right, let's build our Sharpe ratio. Remember, the Sharpe ratio is the risk premium on the portfolio divided by its standard deviation. So let's put that in. We're going to say equals the expected return on our portfolio minus, here's the risk-free rate. I've got it stored down here. The risk-free rate's got an expected return of 0.9% per month. There's my risk premium. The expected return of P minus RF divided by the standard deviation of P, which is right here. Hit Enter, and voila. There's the Sharpe ratio for TiVo, because our portfolio consists of TiVo. If I switch these around, make this 1 and 0, there's the Sharpe ratio of SBC. All right. Let me put in the constraint. Now remember, we're going to tell Solver next that to pick weights, to change these two numbers so that these numbers change, so that the Sharpe ratio change. But the way we want it to pick the numbers is so that all this junk changes so that the Sharpe ratio becomes as big as possible. But we don't want the weights to go off to infinity or do anything too wacky, so we're going to set a constraint, and that is that the sum of these weights, the sum of this column, has to equal the number 1. So let me put that formula in here. Equals sum of W. Just hit Enter that time. And so you can see they already do add up to 1, so I get back 1. All right, let's go to Solver. Go to Solver. Click Solver. It's under the Data tab again. All right, the first thing we want to put in Solver is the objective function, what we want to maximize or minimize. So our objective function, in this case, happens to be the Sharpe ratio. It's in D, for me, it's in D53. So that's already in there. I already got it maximizing. And how do we want Solver to find the maximum of that function? Well, we want it to do that by picking different W's. So I'll just put in the name W for the vector of weights here. All right, we also want to add the constraint. Let me delete this so I can re-add it. I add the constraint that the sum of those of W equals 1. Well, here's a formula for the sum of W. Put that in as a cell reference. We'll say this equals, and this will be the number 1. Say OK. We're ready to go. We'll click Solve. Solver results say Solver found a solution. All constraints and optimality conditions are satisfied. Woohoo! Click OK. And you can see that Solver picked the way, tells us to invest 83.4% of our money in SBC and 16.6% of our money in TiVo. And that'll get us a portfolio with an expected return of 10.01, a standard deviation of 10.74. I'm sorry, 1.01 and 10.74, and a Sharpe ratio of 0.99, almost 1, which is higher than the Sharpe ratio for SBC. All right, that's so cool. If in fact we wanted to add the constraint that the weight, in this case, Solver did find the maximum Sharpe ratio had weights that were both positive here, so we're not short selling either one of these assets. If on the homework problem you find some of the weights that are negative, all that means is that you're short selling that particular asset in that amount, taking that money that you get from the short sell and investing it in the other assets. If you want to restrict Solver from setting the weights to allowing the weights to be negative, you can do that. Let me open Solver again by right here. You can say make unconstrained variables non-negative. Just click that button right there and it'll make sure all your weights come out positive. Okay. Cool. All right, one more thing just to get some more intuition. So what we've done is we've defined the inputs to the algorithm. We've maximized the Sharpe ratio by finding an optimal combination of SBC and TiVo using solver. And let's plot this stuff and see how it looks. Let me copy this down. I'm going to copy down the standard deviation, expected return of P. All right, I've already set this graph up. So here in this graph, we have expected returns on the vertical axis, standard deviations on the horizontal axis. And I've got TiVo plotted here, its standard deviation and expected return pair is plotted right here. SBC's expected return standard deviation pair is plotted right here. This is the risk-free rate. It doesn't have any standard deviation, but it has 0.009% return. And here's our optimal combination of SBC and TiVo. Notice that this portfolio is the best one we can form in terms of maximizing expected return while at the same time minimizing the risk, the standard deviation. The final step, which we started to talk about in class, but we'll finish up next time, is that we're going to take P, this portfolio P right here, and combine it with the risk-free asset. That's going to, all the combinations of those two assets are going to lie along this straight line. That's super cool because everywhere along that line is better in terms of maximizing utility, going up the hill of happiness in this direction, than investing in either SBC or TiVo by itself. So, or even P. Depending on where our hill of happiness falls in this, depending on our A, we can do better. All right, I hope that's helpful. And don't forget to do the case. There's just a couple questions, and we'll see you in 2 weekends.